Okay, maybe right off the bat, memorize these. These will not be given to you on your test. Because of their importance, you need to memorize these two identities. Let's back up a little bit and explain why you need to memorize these. The double angle identities are used in pre-cal and calculus. The others aren't used in calculus very much, but the doubles are. And so since you need it in calculus, we want to make you memorize it here. Obviously, when we hit it in calculus, we'll mention it again. But if you memorize it this year, it'll be easier next year when you see it. In calculus, we use the double angle identities to make differentiation and integration easier. You may not even know what those words are yet, but they're things we do in calculus. And if you know the trig identities, your life can be a whole lot easier. To simplify answers, to obtain the desired multiple choice answers. For pre-cal, we're going to use them to solve equations, and we'll see that in a minute. All right, rather than me just giving them to you, let's come up here at the top and let's do sine of x plus x. So think about the sum identity, but with x and x in it. So do you remember the sum identity? I mean, you can flip back to it if you don't. Sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. But if the first one and the second one are the same, sine x cosine x plus cosine x sine x
should be the same.
Nothing squared. You're not multiplying those, you're adding them.
Equals sine x plus
And those are like terms. They're in different order, but that's still like terms.
2 sine x.
2 sine x cosine x. So there's the hint. Like, memorize them. You're like, well, do you really need to memorize them if I give you the sum formula? I hope not. Like, I would hope you could look at the sum formula and come up with the double formula. So memorize is even like, well, maybe, but maybe not. See if you can do the same type of thing with the cosine. So cosine of x plus x. So look up the cosine sum formula, plug in x for both, and see what happens. So the cosine sum formula is cosine cosine minus sine sine. So what's cosine times cosine? Cosine squared. Sine times sine is sine squared. So there's your double angle cosine formula. Cosine squared minus sine squared. So you have two options. Those are not going to be given. I'll just say it that way. So one option is to memorize them. The other option is to do what we just did and come up with them. My preference is probably that you just come up with them because they're not hard. And then when we give you your formula sheet, you just add those to it and you write those on there. All right, some examples. Given that sine of x equals 12/13, negative 12/13, and is between 3 pi over 2 and 2 pi. So sine of 2x is 2 sine x cosine x. Yeah, so some of this is easy. We already know what sine is. Negative 12/13. How am I going to figure out what cosine is?
But the thing.
Draw it. Do what we did yesterday. Draw the picture of it. So 3 pi over 2 to 2 pi would be fourth quadrant, excuse me. I drew it in the right place. So katoa. So 5, 12, 13. So cosine is adjacent over hypotenuse. And a little bit of work here. 13 times 13 is 169. Multiply on the top. Let's do 2 times 5 first, because that would be easy. 10, and then 10 times 12 is 120. Right? Rather than doing 24 times 5.
Oh yeah, double. It wouldn't that affect the lower one? Well, just the double. 13.
What do you mean? When you multiply fractions, multiply across the top, multiply across the bottom. Cosine of 2x. Cosine squared x minus sine squared x. So cosine squared, we already found this somewhere. 5/13 squared minus negative 12/13 squared. So 25 minus 144 would be 119, negative 119 over 169.
Should be.
Yeah, but when I square it,
It's positive and there's a minus.
well, I didn't give you a formula for tangent of 2x.
It's because there isn't.
There is one, it's kind of annoying, but
Wait, is the bottom one instead of 1 is it 2?
instead of doing the formula, let's just say tangent is equal to sine over cosine. So there's not really a extra formula, we'll just use sine over cosine. And we'll almost always ask them in triples like this, so you won't have to find anything extra. Let's see, sine is negative 1/20 over 169. Cosine is negative 119 over 169.
Times by 169.
So you could multiply by 169 over 169. There's like 3 different ways to go here.
Just cross it out.
You can multiply top and bottom by 169, and they'll cancel. You can cancel them if you know what you're doing. That's really not recommended. Or you could keep it, change it, flip it. That's probably the safest way. Either way, the 169s are going to cancel. So keep it, change it, flip it. 120 over 119. They're both negative, so it becomes positive. Number 2 is worded wrong. Given that cotangent is negative 3/4 and is quadrant 2, which of the following must be true? And then what are we talking about here? Just mark out that second half. Cotangent is negative 3/4, and it just straight up tells us we're in quadrant 2. That's our favorite type of information, right? You can't mess up the, well, I never say never, right? Hopefully you don't mess up the quadrant if we just tell you what quadrant it's in. So adjacent, opposites, the adjacent is the negative one. 3, 4, 5. Why don't you see if you can take it from there? Now you're just using the formulas. We've got the picture. See if you can finish that one out. So you write out the formula, plug in the pieces, don't mess up the multiplying fraction stuff or the signs. So again, this whole unit I feel like is, especially since we're giving you most of the formulas, like just be careful. Draw the picture carefully, careful with the signs, careful with your algebra stuff. Number 3. Cosine squared minus sine squared is equal to which of the following? Ooh, cosine squared minus sine squared. That's cosine of 2 times whatever the argument is, though, right? So it's not cosine of 2x. That's not even one of the options. Of course, when I write it like that, cosine of 2 times 10x would be cosine of 20x. That one's tricky. Like, you recognize what that is, and then be careful. I'm surprised cosine of 2x wasn't one of the choices. Right, now let's use it to solve equations. This is where we combine trig identities with solving equations. Solving equations was the last test. Most of you did well, so most of you will be fine here. Find the values of x between 0 and 2 pi that satisfy this equation. Well, there's nothing I can do with this equation right now, because one's got a 2x and one's got an x. But what's the sine of 2x equal to? Flip back. 2 sine x cosine x minus cosine x equals 0. What can I do now?
Can you move cosine x over and then divide by?
I don't want to divide by cosine, because if I do that, I lose solutions. I could divide out I could factor out a cosine. Cosine x. What's that leave me with?
2 sine x plus 1 minus 1.
2 sine x minus 1 equals 0. And now this really has turned into a problem like what was on the last test. Set both pieces equal to 0. And let's see, cosine 0, pi over 2 and 3 pi over 2. Hey, it's never too late to learn the unit circle, because if you haven't learned it yet, you still need it. Sine of x equals 1/2. Some of you probably don't need pictures at this point. Some of you are like me, you still need to kind of visualize what's going on here. Pi over 6 and 5 pi over 6. Again, the pictures are optional. Grading those last tests, many of you did, but some of you didn't draw the pictures, and that's, show the work you need to show to get the problem right. Number 5, find the x-intercepts. Remember, code word for set y equal to 0 on this interval. This is a similar question, because sine of 2x is 2 sine x cosine x. Why don't you see if you can finish from there? So there's the answers to number 5. It's a very similar problem. Factor out the sine, set the pieces equal to 0, get the answers that are between 0 and 2 pi. I don't want to go too quickly through this, but generally speaking, you guys did well on that test. So the only new stuff is this extra step of plugging in or substituting at the beginning to get rid of the weird stuff. Number 6. Same type question, worded a little differently. What values of x in the interval from 0 to 2 pi satisfy this equation? Well, I'm not going to be able to solve this with cosine of 2x sitting in there, but I know that the cosine of 2x is cosine squared minus sine squared. Okay, so
There's a sign over.
that's sort of helpful maybe, right? Like the 2x thing is gone, but now I have sines and cosines in my problem.
Maybe-
You could change the cosine squared x to, is it 1 minus some?
You ask it really well. You could change the cosine squared to something that we know, right? Because, let's see, out to the side, sine squared plus cosine squared is 1. So cosine squared is 1 minus sine squared. So 2 different trig substitutions to get everything the way we want it to look for this one.
Put the sign over.
Now what?
Have to have a sign.
Combine like terms, and I think I'm going to move them over because right now that's negative. I don't really want negative, so 2 sine squared x plus sine of x minus 1. Man, this one just tests everything. That will factor. Are we u substituting, or are you factoring as it sits? Okay, the 3 people spoke up said as is, so I hope so, because I mean the only way we're going to get 2 sine squared is 2 sine x and sine of x, and the only one at the other end is going to be 1 and 1. So now it's just a matter of the plus and minus stuff, correct? They got to be different signs. I switched to a pencil in case I messed this up. So these need to be different signs.
Right, needs to be minus.
The middle one needs to be positive, so
That one needs to be positive.
the last one, the second one has to be positive.
So that one needs to be the positive pair, to be a plus 2x. And then the middle would be a minus x. So plus 2 minus 1 is plus sign. So you're still guessing and checking, but hopefully you can peek a step ahead so that you're not just like randomly guessing and checking. So now we set both of those equal to 0. So sine of x equals 1/2 at pi over 6 and the other over 6. This is what I get for trying not to draw them. Again, I could draw them and get the answer faster. 5 pi over 6. Sine of x equals -1. That one I can do without drawing because that would be over on the, at the bottom, so that'd be 3 pi over 2. Again, as always, show the work that you need to show to get the answer right. It's not a contest of who can show the least work. That's right. Number 7. Find the zeros.
It's not showing any work today.
Cosine of 2x. Cosine of 2x. That's cosine squared minus sine squared. Dang it, what don't I like about this one?
Like, can you-
There's a sign.
Right, they're not all the same trig function. I can't factor anything out yet.
So we just switch it.
So we can switch it. Which one do you... Well, I think I know which one I want to switch. The sine, because there's only one of them. So sine squared is equal to... Right, we just did this, sort of. Sine squared to be 1 minus cosine squared. Careful with that minus sign out front. It needs to go to everybody. So sine squared is 1 minus cosine squared. again, these problems aren't hard. Like, you know everything you need to know to do them. It's just there's a lot going on. How many algebra steps can I skip at once? Some classes say all of them. I'm not convinced that's a good idea, though. So I'm going to take the time to distribute the minus sign. Combine like terms. 4 cosine squared x minus 3 equals 0. What do you want to do from there?
Fix it.
Well, you may be a
Cosine
step
squared
ahead.
x equals 3,
Yeah, cosine squared x equals 3/4. Square root both sides. So root 3 over 2, because you can square root the top and bottom separately. And if you go with that, you're going to miss half of the answers. What did I intentionally gloss over there to see if everyone's paying attention? The plus or minus. When you put the square roots on, don't forget the plus or minus. But you remember that's good news, because now I don't care about quadrants, because it's all of them. Root 3 over 2 would be the over 6s. So it's all the over 6s. 1, 5, 7, 11 over 6. So I don't feel like today is hard. I feel like today is tricky because it's deceptively tricky, maybe. Like, we give you what you need. And so can you multiply fractions and subtract numbers? I hope so. Can you solve equations? Well, you could on the last test, so hopefully you still can. I'll check on that. So it's worksheet number 3 in the packet is today's assignment. Yep, so it still says no calculator. I think we're going to calculator here.
The first one doesn't.
A lot of them, yeah, they all say it. No calculator. Again, there's one more day of new notes for this unit. That would be on block day. And then Friday, Monday, our review. And then we'll test next Tuesday. And again, I'm out Friday, but that will be your work day to work on the review. And then Monday, I'll take questions on the review.